All right, well, welcome. In this video, we're going to be looking at lesson 2.4, which is going to be all about what we call complex numbers and operations we can do with complex numbers. But first, before we get to that point, let's start with something we are familiar with a problem like this first example, x squared equals 16. Now, if I were to solve this equation for x, I'd want to take the square root of both sides. Now, hopefully remember how many solutions that we would have, because think about it. There's two numbers I could square to get 16. Now, you might say, well, what? I just know the square root of 16 is 4, so wouldn't that be my only answer? Well, remember, if you square a negative number, a negative times a negative is also positive. So our answer for this would be 4 or negative 4. So there'd be two possible solutions because there's two numbers I could square to get 16. So now let's apply that to this next example, where if I take the square root of both sides, I'm trying to find two numbers I could square to get negative 9. Are you stuck? Well, it's not negative 3, because negative 3 squared is 9, and well, obviously 3 squared is positive 9, but there's nothing I could square to get negative 9, and that's true, and this is something that used to stump math teachers for centuries. And so they came up with this idea of an imaginary number, the imaginary unit. We call that letter I, so we'll come back to that in just a second. So let's go down here to this definition. So I represents what we call the square root of negative 1. And there's going to become times where we're going to have to also figure out what I squared is. I squared, just to let you know, is negative 1. Because if we square both sides, that would undo the radicals. That would give us negative 1. So those are two things, two facts you want to make sure that you understand. I is the same as the square root of negative 1, and I squared would be negative 1. And complex numbers, if we stick with that same box, complex numbers are in the form a plus bi. So some examples of things that would be in that form would be things like 2 plus 3i, or negative 5 minus 2i, or even 8i. Those would all be examples of something in a plus bi form, because this last one we could say would be the same as 0 plus 8i. Okay, so let's go back and see how that helps us with this one. So we have the square root of negative 9. And we actually know that there's going to be two solutions, so I'm going to say that it's going to be a plus or minus square root of negative 9. And I'm going to use this first fact, that we know that the square root of negative 1 would be the same as I. So think about this. I could change this to be plus or minus the square root of negative 1 times 9. And the square root of negative 1 would be I, and the square root of 9 would be 3. So we could say plus or minus 3i would be my answer. So 3i and negative 3i would be my two solutions. Well, let's look at the next one. So the next one, we add another level of difficulty here, as if using imaginary numbers wasn't enough. So we're going to take the square root of both sides. So when you do that, we're going to have two solutions. But I can't take the square root of 72. I'm going to write it like this. It doesn't matter what order you write them in, but I'm going to write it like this. So the square root of 72, we want to simplify that. We have some space up here, so I'm going to go up here. Now this is a square root, a second root. So we're going to start by finding any two numbers that multiply together to be 72. Now there's a couple different options. You might be thinking like 2 and 36. You might be thinking what I was thinking, 8 and 9. So there's more than one answer that would be fine to use. And then we're going to break these up. So these are not prime. So we're going to keep going until we end up with all prime numbers. So 8 breaks down to be 2 times 4, and 2 is prime. 4 breaks down to be 2 times 2, and those are both prime. And 9 is the same as 3 times 3, and those are both prime. Now I want to bring your attention to the fact that this is a square root. So there's a rule that we have with square roots, that we can take things out of a square root as long as they come out in pairs. It's kind of like this. Like, let's say, like, I have a home with 4 daughters, and in my home, we allow our girls to leave the house and go for a walk as long as they bring someone with them, even if it's the dog. They can't leave the house alone. So they have to go out in groups of 2. So that's the rule here. These numbers have to go out in groups of 2. So here I have a group of 2 3s. Here I group of 2 2s. So this group of 2s come out as a 2. This group of 3s come out as a 3. And this 2 that's left over, he can't leave home. He's stuck underneath the radical. So this would simplify to be 6 times the square root of 2 times I, which we're going to write as 6i times the square root of 2. So that's a little bit more complicated, but that's how we would simplify a radical. when there's a negative involved. So there's some vocabulary words that we should be familiar with because sometimes they'll say write your answer, round your answer nearest integer or whole number, or rational numbers, irrational numbers. These are all different terms we use. Now, let's start out with real numbers. Any number that we could think of would be a real number. So actually anything in this circle would be real numbers. So real numbers would be, like I said, if I asked you to think of any number right now, it would encompass all of these. So now let's work our way from the inside out. So natural numbers. Natural numbers I like to call the counting numbers. Like if I asked you to count to 10, you would say 1, 2, 3, and so on. You wouldn't start with 0, you'd start with 1. So those are our counting numbers or our natural numbers. Whole numbers adds the number 0 to the group. So whole numbers would be 0 and then 1, 2, 3, and so on. Integers, those include negative numbers now. So not decimals yet, but just negative whole numbers and negative natural numbers. So basically, if you were to create a number line, the numbers that you'd put on that number line would usually be integers going negative and positive. Rational numbers, that includes decimals that terminate, and numbers that can be written as fractions. That would be a rational number. Irrational numbers, those would be like pi or square root of 2, where they would be decimals that never end. Okay, they don't follow a pattern either. So like those are irrational numbers, numbers that don't follow a pattern and that keep going on infinitely forever. And now we have this new set of numbers, these complex or imaginary numbers, or we'd have I or A plus BI. That's a separate category outside of everything else. All right, so that's just some terminology that you should be familiar with. But now let's work with some more things with this A plus BI. So let's look at how we can add or subtract complex numbers. So the first step, whether we're adding or subtracting, the first step is to distribute. So let's do that with this first one. So there's nothing to distribute outside the first parentheses, but outside the second set of parentheses, we have a plus sign. So I'm going to distribute that. So the first set stays 4 minus 7i. And then when we distribute the positive through, a positive times a negative is a negative. A positive times a positive stays a positive. So then the next step is to combine like terms. And now it's important that remember that we're just working with like terms. So 4 minus 11, those are like terms. 4 minus 11 would be negative 7. And negative 7i plus 9i, that would be 2i. But we cannot combine these because these are not like terms. So that was addition. Let's do the same thing with subtraction. So subtraction, we distribute the negative through. So that'll become a minus 2 or a negative 2, and a negative times a negative would make this a positive 5i. So again, we combine like terms. So 6 minus 2 is 4. 8i plus 5i would be 13i. All right, I want you guys to give these last two a shot. So numbers 3 and 4, I want you to practice these on your own. So pause the video and hit play when you're ready to check to see if you've done it correctly. All right, so hopefully you've tried these two on your own. So let's see how you did. So first we distribute the positive through. So this will stay negative 4 plus 6i. And this will be a minus 2. Positive times a negative is a negative, so it'll be minus 9i. Then we combine like terms. Negative 4 and negative 2 would be negative 6. By the way, we are not solving an equation where we're crossing an equal sign. So don't add 2 to the negative 4. They're on the same side. So we combine like terms. So ignore the 6i. So it'd be negative 4 minus 2 would be negative 6. 6i minus 9i would be negative 3i. So that'd be your answer for number 3. And for number 4, we would distribute the negative. So the 3 minus 2i would stay the same. Negative times a negative is a positive, so it'll be positive 4. Negative times a positive is a negative, so that'll be a negative I. Combine like terms. 3 plus 4 is 7. Negative 2i minus I, so negative 2i plus a negative I would be negative 3i. So 7 minus 3i would be number 4. All right, let's talk about how to multiply these. So the first step is you're going to distribute, or we can use the box method. So let's look at how we would do this first one. So we distribute. We have negative 2i, so that's just easy enough just to distribute. So negative 2i times 8 would be negative 16i. And negative 2i times a negative, so a negative times a negative is a positive. And 2i times 9i would be 18i squared. But remember, whoops, I squared is equal to negative 1. Remember what we had up in our box up above. So I squared is negative 1. So that means what we have here is negative 1. So let's simplify this further. So now 18, so let's put this in a plus bi form. So let's put the real number first. So 18 times negative 1 is negative 18. And then that 16i, that's a negative 16i. So my answer, if we put it in this order, would be best. So it'd be negative 18 minus 16i. All right, let's look at number 6. This one we're going to use, and we could distribute. If we distribute, we would distribute this way, where we would take 3 times each of those terms, and then we would take the negative 2i and multiply it times both of those. That can get kind of ugly though. So what I'm going to do is this. I'm going to use what's called the box method. So I'm going to put one factor, 3 minus 2i on one side, and put 3 plus 2i on the other side. So now let's multiply these together. When you do that, 3 times 3 is 9. 3 times negative 2 is negative 6i. 2i times 3, that's a positive 6i. And 2i times negative 2i is negative 4i squared. Let's start with the I squared. Remember, that's negative 1. So in this box, negative 4 times negative 1 would be a positive 4. So remember, I squared, negative 1. So negative 4 times negative 1 is a positive 4. And if I notice, these two cancel out. 6i minus 6i would be 0, leaving me with only 9 and 4. We're going to add those together and get 13. So if you notice, there's something special about those, 3 minus 2i and 3 plus 2i. We'll talk about that tomorrow or in our next video. All right, so let's look at, I want to have you guys do the next one, so number 7. See if you can't, I know it's a fraction, see if you can't do that one on your own. This one, let's actually change, I'm going to change this to be a 6. Because for this box method, I don't want us to have to use fractions yet. So just change this to be 6 plus 2i, 6 minus 2i. So multiply those together and distribute the 2/5 I. So I want you guys to go ahead, pause the video, and hit play when you're ready to check your answer. All right, so for this one, I'm going to rewrite it. I don't like the way that it was written there, so this might make it a little bit easier. So if you had a hard time with this, don't worry. So I distribute the 2/5 I through. So now 2/5 of 10. Now there's a couple ways you could do that. If you want, you could take 2 times 10 and get 20 and divide by 5 and get 4. So it would give you 4i. Or you could divide first, 10 divided by 5 is 2, and then 2 times 2 would be 4, so we also be left with 4i. All right, but when I go to the fraction, I'd multiply the numerators and denominators together. So 2 times 5 is 10, 5 times 2 in the denominator is also 10, and 10 divided by 10 is 1, so we left with, and it's I times I, so we left with 1i squared. Now remember, I squared is negative 1. So we would have a negative 1, which would become a positive 1. That's a positive 4i. So that's a little tricky. That's probably one of the hardest ones in this page. All right, let's end by looking at this one here. So again, we can do the box method. So we multiply these together. 6 times 6 is 36. 6 times 2 is 12i. Negative 2i times 6 is negative 12i. And negative 2 times 2 is negative 4i squared. But again, just like we had the same problem in the previous one. Negative 4i squared would be the same as negative 4 times negative 1, which would make that a positive 4. And also you should recognize that 12i minus 12i cancels out like the previous one, and we're left with 36 and 4. 36 plus 4 is 40. So hopefully you got that one right. Well, that's it. That's the first part of lesson 2.4, where we're just introduced to complex numbers and some simple operations we can do with complex numbers.